Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into time, not just as something your clock measures, but as something far stranger, something that may already hold your past, your future, and every moment in between, all at once. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a gentle reminder that while we share this space together, we each sit in our own little moment of time. Now, feel free to dim the lights. Maybe turn on a fan for a soft background hum. And let's gently begin our journey into time travel together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Tonight, we begin not with equations or machines or distant galaxies, but with something much simpler, a moment, a choice, and a letter that should never have existed. It is a cold, moonless night, the kind where the air feels heavy and sound seems to move more slowly, as if even the world itself is a little unsure of where it's going. A thin mist hangs over the road, softening the edges of everything you see. You step forward to cross the street. There is a moment, just a moment, where everything feels still. And then suddenly, there is movement. Headlights break through the fog, too close, too fast. You realise what is happening at the exact same time that it becomes impossible to stop it. Your body tenses, your breath catches, there is no time left to react, and then a hand, firm, unexpected, urgent. Someone shoves you sideways out of the path of the car. You fall hard onto the pavement, the world spinning around you, the sound of impact echoing behind you instead of through you. When you look up, dazed and disoriented, you see the figure who saved you lying motionless in the road. An elderly stranger. They never speak, never move again. Their life ends quietly, in the place where yours almost did. In the days that follow, everything feels slightly unreal, like you've stepped out of one version of your life and into another, without quite understanding how. At the police station, an officer hands you a small envelope. It was found in the stranger's pocket. It is addressed to you, your name, written in careful, deliberate handwriting. Inside there is only a single note, 2 words, study physics, that's all, no explanation, no signature, no clue as to why someone you have never met would carry a message meant only for you. And yet, they gave their life to deliver it, so you follow the instruction, not all at once, not dramatically, but slowly, steadily, over the years that follow, you find yourself drawn toward the quiet logic of the universe. You study motion, light, gravity. You learn that time is not as simple as it feels, that it can stretch, bend, even behave differently depending on how you move. And somewhere along the way, a thought begins to settle in your mind. What if time is not something that simply passes? What if it can be navigated? Decades pass. You become a physicist, then a professor, then something more. Your work narrows, slowly but inevitably, toward one idea: time travel. At first, it is a question, then a theory. Then, finally, something real. One day, after years of quiet effort, something hums to life in front of you. A machine. Small, contained, almost unimpressive at first glance. But you know what it is. You can feel it. It is the answer to a question you've been asking your entire life. A way to move through time. Not just forward, as we all do, but freely. And then, something shifts. A realization, slow and heavy, like a memory returning. You look at the machine, you think of the letter, you think of the night, and suddenly the pieces fall into place. How had you not seen it before? You walk to the wall where the envelope has been kept all these years, preserved like something sacred. You take it down carefully, you hold it in your hands, you place the note back inside, and for a moment, you hesitate. Because now, for the first time, you understand what this means. If you step into that machine, if you go back, then the stranger who saved you was never a stranger at all. It was you, older, slower. At the end of your life instead of the beginning, you step inside. The world softens, the machine hums, and when it stops, you're standing once again on that same quiet road, beneath the same dark sky, wrapped in the same drifting mist. You see your younger self stepping forward, you see the headlights, you feel the weight of what must happen. There is no room for doubt now, no space to choose differently. You move, you push. And in that instant, as the world folds back into the shape it has always held, you understand something strange and unsettling. You are always going to be here. The story does not begin with the letter, or the machine, or even that night. It simply exists, looping quietly through time, a moment that causes itself, a life that closes back on its own beginning. And as you lie there, in the silence that follows, one final question drifts gently through the space between thoughts. If the letter was never written, then how did it come to exist at all? And perhaps more quietly still, if your future led you here with no way to change it, were your choices ever truly yours? These questions do not arrive loudly. They do not demand answers. They simply linger, like the fading echo of footsteps in the mist. And as we begin to sit with them, something even deeper begins to emerge. Not just a story, but a pattern. A set of strange, almost impossible ideas that seem to sit just beneath the surface of time itself. Ideas that suggest that the way we experience time may not be the way it truly is. And so, gently, almost without noticing, we begin to turn away from the story and toward the quiet structure behind it. As the mist of that quiet night begins to settle in your mind, the story lingers. Not because of what happened, but because of what it implies. At first it feels almost complete. A life saved, a path followed, a discovery made, a sacrifice returned, a loop closed. There is something strangely satisfying about it. Everything connects, everything resolves, and yet, the longer you sit with it, the more something begins to feel off, not dramatically, not in a way that demands attention. Just a quiet misalignment, like a note slightly out of tune. And if you follow that feeling, if you allow your thoughts to move gently back through the events, one question begins to form. Where did the letter come from? Not who carried it, not who delivered it, but where it truly began. Because when you trace its path, carefully, patiently, it seems to lead nowhere at all. You received the letter as a young person, you kept it, you carried it through your life, and then, much later, you brought it back in time and gave it to your younger self. The letter exists. You can hold it, read it, preserve it, but there is no moment in which it was created, no pen touching paper for the first time, no thought forming the words. It simply is, an object without an origin, a message that was never written, and yet somehow exists. This is what physicists and philosophers gently call a bootstrap paradox. But you don't need the name to feel its strangeness, because the deeper you think about it, the more it begins to resemble something impossible. A book that was never written, yet has always been read. A melody that no one composed, yet continues to play. And then, just as you begin to settle into that thought, another detail emerges: the letter. Paper is not timeless. Ink fades, edges soften, fibres weaken. Each time the loop completes, the letter would have been carried once more through years, through decades, through handling, folding, unfolding. So what happens to it? Does it slowly age, becoming more worn with each cycle? Or does it somehow remain unchanged, as if protected from the passage of time? If it ages, then something strange happens. A single object accumulates history without ever having a beginning, a kind of quiet erosion without an origin point. This idea is sometimes described as a restoration paradox, but again, the name is less important than the feeling it evokes, because it suggests that time, in this case, is not flowing cleanly forward, but circling, layering, repeating. And within that repetition, something begins to drift. Something begins to wear down, like a memory told too many times. And then, perhaps most quietly of all, there is the question of the message itself. Study physics, a simple instruction, clear, direct, life-changing. But where did that idea come from? You followed it, you lived it, you fulfilled it, but you never created it, and neither did anyone else. The thought appears in the letter, and nowhere else. It has no source, no origin in a mind, no moment of invention. It simply enters existence, already formed. This is what is sometimes called an ex nihilo paradox, a phrase that gently translates to from nothing, an idea born from nowhere. And if that feels unsettling, it's because it touches something deeper than time travel itself. It raises a question about information, about knowledge, about whether something can exist without ever being created. And as that thought settles in, another layer begins to reveal itself. Because if the letter always existed, if the loop always completes, if the older you always returns, then what does that say about choice? When you first received the letter, it may have felt like a suggestion, a possibility, a path you could choose or ignore. But now, looking back, it begins to feel different. Because if you had chosen not to follow it, then you would never have built the machine. And if you never built the machine, then you would never have gone back. And if you never went back, then no one would have saved you. Which means you would not be here at all. And so the path you thought you chose may have been the only path that could ever exist. Not because someone forced you, but because the structure of events leaves no room for anything else. This quiet, almost invisible constraint is often described as a predestination paradox, a situation in which the future seems to reach back and shape the past, not loudly, not violently, but gently, persistently, ensuring that certain things always happen. And perhaps the most unsettling part is how natural it feels, because nothing in your experience ever told you that you didn't have a choice. You still thought, decided, acted, and yet, every one of those choices may have already been part of the loop, already written into the structure of time. And then, finally, there is one last question, a small one, almost easy to miss. What if, at the very end, standing beside the road, you hesitated? What if, for just a moment, you decided not to act? What if you stepped back and let the younger version of yourself be struck by the car? It seems like a choice, a simple one, and yet something about it feels impossible, because if you had chosen not to act, then you would not have survived to become the person standing there, which means you could not be there to make that choice in the first place. In other words, the decision to not act cannot exist. It cancels itself out. This is sometimes referred to as the auto-infanticide paradox. But beneath the name, the idea is simple. There are actions that cannot happen, because if they did, they would erase the very conditions that allowed them. And so, quietly, gently, they are never taken, not by force, not by rule, but by the structure of reality itself. And as all of these thoughts begin to settle, the story you began with starts to feel different, not broken, not impossible, but deeper, more intricate, less like a simple loop, and more like a glimpse into something larger, something that suggests time is not just a sequence of moments, but a structure, a shape, a landscape in which events are not merely happening, but already exist. And if that is true, then perhaps the question is no longer, can we travel through time, but something softer, something quieter, something that begins to unfold like a slow ripple across still water. What is time, if it can fold back on itself like this? If you let the story rest for a moment, if you allow those paradoxes to settle like dust in still air, something quieter begins to take their place. Not an answer, but a feeling, a sense that perhaps the strangeness we just encountered does not come from the story itself, but from the way we think about time. Because most of us carry a very simple picture of time in our minds. It feels like a line, or perhaps more accurately, just like a flow, something that moves, something that carries us forward. We wake up in the morning, we move through the day, and by the time evening arrives, the morning feels distant, almost as if it has slipped away and disappeared. And tomorrow feels like something that does not yet exist. It waits somewhere ahead of us, hidden, unreal, waiting to be formed. But what if this picture is not quite right? To explore that, it helps to imagine something more familiar. A river, not a rushing, violent river, but a wide, steady one. The kind that moves slowly through a quiet landscape. You're sitting in a small boat resting gently on its surface. The current carries you forward without effort. You don't need to paddle. You don't need to steer. You simply drift. As you move, the scenery changes. The trees you passed a moment ago slip behind you. The bend in the river ahead slowly approaches, and it feels very much like time. You are carried from what you call the past into what you call the future, and just like in life, you cannot turn the boat around. You cannot move against the current. You cannot return to the stretch of water you've already passed. At least, not in any way that feels natural, so it seems obvious. The part of the river behind you is gone, and the part ahead of you does not yet exist. Only this moment, the water directly beneath you, feels real. But if you pause for just a moment and look at this idea more carefully, something begins to shift. Because if you were standing on the riverbank instead of drifting in the boat, you would never say that the upstream part of the river has vanished. You know it's still there. You could walk back along the bank and see it again. You could point to it on a map. You could even imagine someone else standing there right now looking at the same water you passed minutes ago. The river does not disappear behind you, you simply move through it. And yet, when it comes to time, we instinctively think differently. We imagine that yesterday has somehow ceased to exist, that it has been erased or dissolved or folded away into nothing. But why would time behave so differently from space? Why would the places of the past vanish when the places of the river do not? And then there is the future. We tend to think of it as something that has not yet been created, as if tomorrow is still empty, waiting to be filled. But again, if you return to the river, that idea begins to feel less certain. The stretch of river ahead of you already exists. It does not suddenly appear the moment you arrive. It was always there, you simply had not reached it yet. And so, slowly, gently. A different picture of time begins to emerge, one that feels less like a flowing current and more like a landscape in which every moment, past, present, and future, exists all at once. Not in the sense that you experience them all at once, but in the sense that they are all part of the same structure, already laid out, already there. In this picture, what we call now is simply the point where we happen to be, the place where our awareness rests. Just as you sit in your boat at one point along the river, while the rest of the river stretches both behind and ahead of you. And if that is true, then something subtle but important changes. The past is not gone, it is simply elsewhere. The future is not unreal, it is simply not yet reached. And the present, the moment you feel so strongly, may not be special in the way you imagine. It may simply be your position, your location in time. This idea has been explored for centuries. Philosophers have debated whether only the present truly exists, or whether the past and future are just as real. Some have argued that the present is all there is, that the past has vanished, and the future has not yet come into being. This view is often called Presentism. It matches our intuition. It feels natural, but others have suggested something very different. They have proposed that all moments exist equally, that the past, present, and future are all part of a single complete structure, a vast, unchanging whole. This view is known as eternalism. And while it may sound abstract, even a little unsettling, it begins to align more closely with what physics tells us about the universe. Because as scientists began to study time more deeply, they discovered something surprising. Time does not behave the same way for everyone. Two people moving differently can disagree about how much time has passed. Clocks can tick at different rates depending on where they are and how they move. And when you begin to see time in this way, not as a universal flow, but as something that can stretch and bend, the idea of a fixed flowing present begins to loosen. It becomes harder to argue that there is one single now that everyone shares, and easier to imagine that all moments exist, each in their own place, like points along a vast invisible landscape. And if that is the case, if time is not something that moves, but something that is, then perhaps the river was never flowing at all. Perhaps it only feels that way because we are the ones moving, drifting gently, quietly, through a structure that has always been there. And as that thought settles in, something else begins to follow. Because if all moments already exist, if the past is still there, and the future is already laid out, then the strange loop we began with, the one that seemed so impossible, begins to feel a little less like a violation of reality, and a little more like a glimpse into its deeper shape, a shape we're only just beginning to understand. As you continue to drift along this quiet river of thought, something begins to settle into place, not as a firm conclusion, but as a possibility. The idea that what we call the past may not have vanished, and what we call the future may not be waiting to be created, but instead, both may already exist, quietly, steadily, just beyond where we are. At first, this can feel difficult to accept, because your experience tells you something very different. You remember yesterday, but you cannot return to it. You can imagine tomorrow, but you cannot touch it. And so it feels natural to believe that one is gone, and the other is not yet real. But experience can be deceptive. There are many things that feel obvious, until we look at them more closely. Consider something simple, a photograph, perhaps one taken years ago. When you look at it, you see a moment that has already passed. People standing together, smiling, frozen in a time that you can no longer visit, and yet the moment itself has not been erased from existence. It still exists in the structure of the universe, not as a memory, but as an event that happened at a particular place, at a particular time. You cannot step back into it, but that does not mean it has disappeared. It simply means you're no longer there. In the same way, there may be moments in the future where people are standing, talking, living lives that, from your current position, have not yet unfolded. But from the perspective of the universe, those moments may already exist, just as real as the one you are in now. This idea can feel strange because it challenges something very deeply held, the sense that time is something that is being created moment by moment. But if time is more like a landscape, then creation may not be the right word. Instead, it may be more accurate to say that all moments are part of a larger structure and that we simply move through it. And this brings us back to those two quiet philosophical ideas, Presentism and eternalism. Presentism suggests that only this moment exists, that everything behind us has faded away, and everything ahead of us has yet to come into being. It is a comforting idea. It places us at the center of reality. It tells us that the present moment is special, that it is the only thing that truly is. But eternalism offers a different perspective. It suggests that all moments exist equally, that the past is not gone, that the future is not unreal, that everything, every event, every conversation, every quiet evening and distant memory is part of a vast unchanging structure, not flowing, not evolving, but simply existing, like pages in a book that has already been written. You may be reading page 1, someone else may be reading page 100, but both pages exist at the same time. They are simply being experienced at different points, and in this view, the present moment is not special because it exists, but because it is where you are, a location, not a universal truth. This idea has been explored for thousands of years. Ancient philosophers wondered about it. Some describe the present as a thin boundary, like the edge of a blade, separating what has been from what will be. A moving edge, always shifting, always dividing. But if the past and future do not truly vanish, if they remain part of the same structure, then that boundary may not be as fundamental as it feels. It may simply be a feature of our perception, a way our minds organize experience. And as science began to develop, this philosophical idea found something unexpected: support. Because when physicists began to study time, not just as something we feel, but as something that can be measured, they discovered that time behaves in ways that challenge the idea of a universal present. Two people moving differently can disagree about the order of events. One observer may say that event A happened before event B. Another, moving at a different speed, may say that event B happened before event A, and both are correct. There is no single, shared timeline that everyone agrees on. No universal clock ticking in the background. Instead, time becomes something more flexible, something that depends on motion, on perspective, on the path you take through the universe. And when that happens, when the idea of a single, shared now begins to dissolve, eternalism starts to feel less like a strange philosophical idea and more like a natural consequence. Because if different observers can disagree about what is happening now, then perhaps there is no single now at all. Perhaps all moments simply exist, and what we experience as the present is just one slice through that structure, like a beam of light passing through a vast still space, illuminating one region at a time. And if you follow that idea just a little further, something else begins to emerge. Because if all moments exist, then somewhere in that structure there are people who have not yet been born, living their lives, and somewhere else there are people long gone, still existing in their own moments, not as ghosts, not as memories, but as real events, fixed in place within the fabric of time. It does not mean we can visit them, it does not mean we can interact with them, but it suggests that they are not lost, only out of reach. And this brings us gently, almost imperceptibly, back to the question we began with. If all moments exist, if time is not flowing but laid out, then what does it mean to move through it? What does it mean to travel? Because if moving through space simply means changing where you are, then perhaps moving through time is not so different. Perhaps it is not about creating new moments, but about finding ways, however subtle, however difficult, to reach ones that already exist. And as this thought begins to take shape, something shifts once more. The river becomes something wider, the story becomes something deeper, and the question of time travel no longer feels like science fiction. It begins to feel like a question about the structure of reality itself. If you sit with that idea just a little longer, that time may not be flowing, but instead laid out, something begins to take shape in your imagination, not as a river anymore, but as something more still, more complete. Imagine for a moment that the entire universe is like a book, not one that is being written as you read it, but one that is already finished, every page in place, every sentence set, the beginning, the middle, and the ending all existing at once. You, however, experience it differently. You read it line by line, page by page. You cannot jump ahead, at least not in the way you normally live. You cannot return to earlier pages, except in memory. So it feels as though the story is unfolding, but the book itself is already complete. And in this quiet analogy, something important is revealed. The sense of time passing may not come from time itself. It may come from the way we move through it. This idea, when explored through physics, becomes what is often called the block universe, a view of reality in which space and time are not separate things, but part of a single, unified structure, spacetime. You can think of space as describing where something is, and time as describing when it is there. But instead of treating them as separate, physicists discovered that they are deeply connected, woven together, not unlike threads forming a fabric. To understand this more gently, imagine placing a small dot on a sheet of paper. That dot marks a location. Now imagine adding a second dimension, not of space, but of time. Instead of a single dot, you now have a series of dots, each representing where something is at each moment. If you connect those dots, they form a line, a path, a story of where that object has been and where it will be. This path is sometimes called a world line, but you can simply think of it as a trace, a quiet record of movement through time, even if something appears still, even if it is resting on a table, unmoving, its world line continues, because time is still passing. Each second adds another point, another position, not in space, but in time. And if you extend this idea outward, if you imagine not just one object, but everything, every person, every particle, every star and planet and drifting cloud of dust, each one tracing its own path through space-time, then what you begin to see is not a sequence of events, but a vast structure, a tapestry, a four-dimensional shape where every moment, every location, every interaction is already part of the whole. In this view, nothing is being created moment by moment. Nothing is vanishing into the past. Instead, everything exists within this structure, fixed, complete, and your experience of time The feeling that things are changing is simply the result of moving along your own path within it. Like a finger tracing a line on a page, the line is already there, but the movement of your finger gives it life. This idea may feel abstract at first, but it begins to align beautifully with what physics tells us. Because early in the 20th century, a scientist named Albert Einstein began to explore how time behaves under different conditions, and what he found was deeply surprising. Time is not the same for everyone. It does not tick at a universal rate. Instead, it depends on how you move. Two people travelling differently can measure time differently. One may experience more time passing than the other, and both will be correct. This means that there is no single, shared timeline that everyone agrees on. No universal clock in the sky that dictates what is happening now for the entire universe. Instead, each observer carries their own sense of time, shaped by their motion through space. And when you take this idea seriously, when you allow it to unfold, the concept of a single, moving present begins to dissolve. Because if there is no universal now, then what is the present? Is it a real thing? Or is it simply your position along your own path? This is where the block universe becomes not just a philosophical idea, but a natural consequence of physics. If time can stretch, if it can differ between observers, if there is no single moment that everyone agrees is happening right now, then it becomes much easier to imagine that all moments exist, each one anchored in place, each one part of the same structure. And in this structure, your life is not a sequence of events being created one after another, but a continuous path, a line that stretches from what you call your beginning to what you call your end. Every choice you will ever make, every place you will ever go, every quiet moment like this one, already part of that line, already part of the shape of the universe. This can feel unsettling at first, because it raises questions about freedom, about choice. If everything is already part of the structures, then are you truly deciding anything? Or are you simply following a path that has always been there? But perhaps that is not the most helpful way to think about it. Because even if the path exists, you are still the one experiencing it. You're still the one making decisions, feeling emotions, moving through each moment. The path may be fixed, but the experience is still yours, and that experience is what gives meaning to the structure. Without it, the universe would be silent, still, unobserved. So, in a way, you're both, a path and a traveller, a line and the awareness moving along it. And as this idea settles gently into place, something else begins to follow. Because if time is part of a fixed structure, if all moments already exist, then the idea of travelling through time begins to shift. It is no longer about creating new moments, or rewriting the past, or jumping into a future that does not yet exist. Instead, it becomes something quieter, something more subtle, a question of movement, of whether it is possible, under the right conditions, to move through this structure in ways that are not normally accessible, to follow a different path, to reach a different point, to arrive somewhere that your ordinary journey would never take you. And as that possibility begins to form, slowly, gently, we find ourselves standing at the edge of something remarkable. Because while travelling backward may remain uncertain, there is one direction, one quiet, undeniable direction, in which time travel is not only possible, but already happening, all around you, all the time. If the universe is something like a finished book, if every moment already exists quietly resting in place, then the next question begins to form almost naturally. What then are you? not just as a person moving from one day to the next, but within this larger structure. Because if time is not flowing, if it is laid out, then you're not being carried forward like a passenger on a river. You are something else, something more like a path. To understand this, it helps to return to something simple. Imagine placing a single point on a sheet of paper. That point marks a location. Now imagine placing another point, just slightly to the right, and another, and another. If you continue this process, slowly and steadily, those points begin to form a line, a trace of movement, a quiet record of where something has been. Now imagine that each point does not just represent a position in space, but also a moment in time. Each point says, this is where something is, at this moment. And when you connect all those points together, you get a complete picture. Not just of where something is, but of how it exists through time. This is what physicists gently describe as a world line. But you don't need the term to understand the idea, because in a very real sense, you are one. Not a single point, not a single moment, but a continuous thread stretching through time. Right now, as you sit or lie here, listening, there is a version of you that existed a second ago, and another version a second before that, and another, each one slightly different, each one connected. If you could see all of them at once, not just the present moment, but every moment of your life, you would not see a single person. You would see a long, continuous shape, a path, a quiet line stretching from your earliest memory to a future you have not yet experienced. And that line is not something that is being drawn as you go. It is already there, part of the structure, part of the fabric of space-time. This idea can feel a little distant at first, a little abstract, so it helps to bring it closer, to imagine something familiar. Think of a candle. When it's lit, the flame flickers, changing shape from moment to moment. If you take a photograph of the flame, you capture one instant. But if you take many photographs, one after another, and place them side by side, you begin to see not just the flame, but its movement. Now imagine stacking those images together, not side by side, but along a new direction, each layer representing a moment in time. What you would see is not a single flame, but a shape, a three-dimensional form made of all the moments of the flame combined. And in the same way, you're not just the person you are right now, you're the sum of every moment you have ever been. A shape that extends through time, a structure that includes your past, your present, and your future, all at once. And within this structure, each moment is fixed, not frozen in the sense of being lifeless, but fixed in the sense of having a place, a position, a coordinate in space-time. Three directions describe where something is, and one gentle, quiet direction describes when it is there. Together they form a kind of address, a way of locating any event in the universe, and every point along your path, every moment of your life, has such an address. You're here, now. But there are also versions of you that are elsewhere, in time, not gone, not erased, just located at different points along your path. And as you move, as your awareness shifts from one moment to the next, you trace that path, you experience it, you bring it to life. It can be tempting to imagine that you're moving forward through time, but from another perspective, it may be just as true to say that your awareness is moving along a path that already exists, like a small light travelling along a thread, illuminating one point at a time. And this brings us gently to something subtle but important, because if your path through time is already laid out, then what determines its shape? Why does your world line look the way it does? Why do you go where you go, meet who you meet, become who you become? Part of the answer lies in the choices you make, but part of it also lies in the structure of the universe itself, in the rules that govern how things move. Because not all paths are possible, there are limits, constraints, gentle boundaries that shape what can happen and what cannot. For example, there is a maximum speed at which anything can move through space, a speed that light itself travels. It is not just a number, not just a measurement. It is a kind of limit woven into the fabric of reality. And as strange as it may sound, this limit affects how you move through time as well, because space and time are not separate, they are linked. If you move more through space, you move differently through time, and if you move less through space, time behaves differently again. It is as if you have a kind of balance, a quiet trade, a way of distributing your motion between space and time. You do not notice it in everyday life. The differences are far too small, but at very high speeds, or in very strong gravitational environments, the effect becomes real, measurable, and deeply important. But we will come to that gently, in time. For now it is enough to feel this shift in perspective, to sense that you are not just moving through time, you are a path within it, a continuous presence, stretched across moments, and that path is part of something larger, a vast interconnected structure where every event has its place. And as this idea settles in, softly, quietly, it begins to open the door to something remarkable, because if you are a path through time, and if that path is shaped by how you move through the universe, then perhaps under the right conditions, that path could be bent, stretched, or even altered, not in a dramatic, impossible way, but in small, subtle ways that allow time itself to behave differently. And as we begin to explore that possibility, the story shifts once more from what time is to what it can do. If you stay with that thought, that your life is a path through something larger, then another idea begins to emerge almost naturally. That path is not arbitrary. It is shaped, guided, constrained in subtle ways by the structure of the universe itself. And one of the most important of those constraints is something you already know, even if you've never thought about it this way. There is a maximum speed in the universe. Nothing can move faster than light. Not a spaceship, not a signal, not even information itself. Light travels incredibly quickly, so fast that it can circle the Earth many times in a single second. But even so, it has a limit. And that limit is not just a property of light, it is a property of reality. At first glance, this may seem unrelated to time. After all, speed feels like something that belongs to space, to movement, to distance. But as scientists began to look more closely, they discovered something surprising. Speed and time are not separate. They are connected, deeply. To understand this connection, it helps to imagine something simple. Imagine that you're given a kind of budget. Not money, not energy, but something more abstract. A fixed amount of motion. You can spend this motion in different ways. You can use it to move through space, travelling from one place to another, or you can use it to move through time, experiencing moments one after another. But the total amount, the combined motion, remains constant. It is always the same. Now, in everyday life, you are not moving very fast through space. You walk, you drive, you sit. Compared to the speed of light, your motion is gentle, almost still, and so almost all of your motion budget is spent moving through time. Second after second, minute after minute, your life unfolds at a steady pace. But what happens if you begin to move faster? Not just a little faster, but dramatically faster. Imagine stepping into a spacecraft. It accelerates smoothly. faster and faster, until you're travelling at a speed so high that it begins to approach the speed of light. Now something subtle begins to change. From your perspective, everything feels normal. Your heartbeat, your thoughts, the ticking of a clock beside you. But for someone watching from far away, something different is happening. They see your clock ticking more slowly. They see your movement stretching out. From their point of view, time is passing more slowly for you. And this is not an illusion. It is not a trick of perception. It is a real, measurable effect. Because as you spend more of your motion moving through space, less remains for moving through time. Your time motion slows down, gently, quietly, almost imperceptibly at first, but more and more noticeably as your speed increases. This effect is known as time dilation. But you don't need the term to understand the feeling, because at its heart it is simply this: the faster you move through space, the slower you move through time, and the reverse is also true. If you remain still in space, if you drift quietly, then you move more fully through time. Now, this may sound abstract, so it helps to bring it closer, to imagine a story. Two people begin together. They share the same moment, the same place, the same starting point. Then one of them leaves. They travel away, faster and faster, eventually reaching speeds close to that of light. They continue for a long journey, moving through space at incredible speed. And then, one day, they return. They meet again. They stand side by side just as they once did. But something has changed. The traveller has aged less. Not dramatically, perhaps, but measurably. From their perspective, only a certain amount of time has passed. But for the person who remained behind, more time has passed. They are older. This is sometimes called the twin paradox. But it is not truly a paradox. It is simply the natural consequence of how motion through space affects motion through time. And while it may seem like something that only happens in distant, extreme situations, it is actually happening all the time, on a very small scale, in ways we do not notice. Even now, as you sit here, you are moving. The Earth is rotating beneath you. The planet is orbiting the sun. The solar system is moving through the galaxy. And all of this motion, subtle as it may seem, affects the way you move through time. The differences are incredibly small, far too small to feel, but they are there, quietly shaping your path, quietly adjusting the rhythm of your existence. And as this idea settles in, something else begins to follow. Because if time can slow down, if your movement through it can change, then in a very real sense, you're already travelling through time. Not just forward, as everyone does, but at slightly different rates, depending on how you move. It is not dramatic. It is not something you can control, but it is real, and it is measurable. And in that quiet realization, something remarkable begins to take shape. Because time travel, in one direction at least, is not a fantasy. It is not a distant possibility. It is already part of the universe. Already woven into the fabric of reality, already happening gently, continuously, all around you. And as we begin to explore this more deeply, to move from intuition into evidence, from idea into experiment, we will find that the universe has already shown us, again and again, that time is far more flexible than it first appears. If you follow that idea just a little further, that your movement through space shapes your movement through time, something else begins to appear. A kind of boundary, not something you can see, not something you can touch, but something that quietly defines what is possible and what is not. Because even though your path through time feels open, Even though the future seems wide and full of possibilities, there are limits, gentle ones, hidden ones, limits that shape the very structure of what you can reach. To feel this more clearly, it helps to imagine a simple situation. Picture yourself standing still, right where you are. Now imagine that 1 second passes, just one. In that single second, how far could you possibly move? Even if you had the fastest vehicle imaginable, even if you could travel at the ultimate speed limit of the universe, you could only go so far, a certain distance, no further. Now imagine 2 seconds passing. You could go a little farther, 3 seconds, farther still. And as time continues, the region you can reach begins to expand. It grows outward, not in a straight line, but in all directions, like a ripple, or like a sphere slowly expanding around you. At each moment there is a limit to how far you could possibly be from where you started, a boundary defined by time and by the maximum speed anything can travel. If you could see this boundary, if you could draw it, it would form a kind of shape, a soft, expanding form that grows as time passes. Physicists sometimes describe the shape as a light cone, but you don't need the name to understand the idea, because what it represents is something quite simple. All the places you could possibly reach, given the passage of time. Everything inside that boundary is accessible, everything outside it is not. At least, not without breaking the fundamental rules of the universe. And this applies not just to space, but to time as well. Because just as there are places you can reach in the future, there are places you cannot. There are events that can affect you, and events that cannot. There are moments that can be connected to your path, and moments that lie forever beyond it. Now imagine this not just as a single expanding shape, but as something that extends both forward and backward. Forward into the future, where your possibilities spread outward, and backward into the past, where events converge toward where you are now. Together, these regions form a kind of structure around you, a shape that defines your relationship with the rest of the universe. And within this shape, your path unfolds. Your world line, as we described earlier, must always remain inside this boundary. It cannot suddenly jump outside it. It cannot leap beyond what is possible, because doing so would require something impossible. It would require moving faster than light. And that is where something interesting happens. Because earlier we imagined that time travel to the past might involve bending your path, looping it back on itself, returning to an earlier point. But now, with this picture in mind, that idea becomes more difficult. Because to loop your path backward, to reach a moment behind you, you would have to step outside this boundary. You would have to move in a way that the structure of space-time does not allow. It would be like trying to jump beyond the edge of your own shadow, or stepping outside the limits of your own reach. And so, from this perspective, time travel to the past seems forbidden. Not because of a rule written somewhere, but because of the geometry of reality itself, because of the shape of what can be reached. And yet, as with many things in physics, the story does not end there. Because while these boundaries are strict, they are not always rigid. Under certain conditions, the structure of space-time itself can bend, it can stretch, it can curve, and when it does, these boundaries can tilt, not disappear, but shift. Imagine, for a moment, that the surface you're standing on begins to slope, gently at first, then more steeply. The directions that once seemed fixed begin to change. What was once forward begins to lean. What was once out of reach begins to move closer. In the same way, if space-time becomes curved enough, if the structure itself is altered, then the boundaries that define what you can reach may also change. Your light cone, your region of possible movement, may tilt, and if it tilts far enough, something remarkable begins to happen. Paths that once led only forward begin to bend, they begin to curve, and in extreme cases they may even loop, returning to points that once seemed unreachable, returning to the past. But this requires something extraordinary, because space-time does not curve easily. It takes immense energy, immense gravity, conditions far beyond anything we encounter in everyday life. And so, while the idea of travelling backward through time is not completely ruled out, it lies at the very edge of what is possible, at the boundary where the structure of reality itself begins to stretch. And this brings us to a quiet realization, because while travelling to the past may require bending the universe in extreme ways, travelling to the future requires no such effort. It is already happening, all the time, gently, naturally, and in ways that we can observe, measure, and understand. Because while the boundaries of the past remain distant, the future is something we are already moving into. With every second that passes, with every moment you experience, you're stepping forward, following your path, tracing your line through space-time, and under the right conditions. That forward journey can change, it can stretch, it can allow you to move into the future faster than others, not by breaking the rules, but by following them. And as we begin to explore those conditions, to see how the universe itself allows this quiet form of time travel, we move from possibility into reality, from imagination into experiment. High in the mountains, where the air becomes thinner and the world feels just a little closer to the sky, something unusual was being measured. Not something large, not something you could see with your eyes, but something fleeting. Tiny particles created far above the earth, falling silently toward the ground. They arrive constantly, unnoticed, passing through your body, through the air, through the ground beneath you. They are called muons, and in many ways they are like echoes, fragments born from collisions high in the atmosphere when energetic particles from space strike the upper layers of air, breaking apart into cascades of smaller pieces. Among those pieces, muons are created, but muons have a problem. They are unstable. They do not last long. If you could imagine their existence as a kind of ticking clock, it would be a very short one. On average, a muon exists for only a tiny fraction of a second, just a brief flicker, and then it transforms into something else. So brief, in fact, that if you calculate how far a muon should travel before disappearing, the answer is surprisingly small. Even if it moves incredibly fast, even if it travels at almost the speed of light, it should not make it very far, certainly not all the way from the upper atmosphere down to the surface of the Earth. And yet, they do, again and again. Muons created high above us are detected at ground level, in numbers far greater than expected. It is as if something is allowing them to survive longer than they should, long enough to complete a journey that, by all simple reasoning, should be impossible. This quiet mystery drew the attention of a physicist named Bruno Rossi. He wanted to understand what was happening. So he carried his instruments up into the mountains. Higher altitude meant being closer to where the muons were born, and allowed him to compare how many were detected at different heights. What he found was not just interesting, it was profound, because the explanation did not lie in the particles themselves changing, but in time behaving differently for them. To understand this, return for a moment to the idea we explored earlier, the idea that movement through space affects movement through time. That if something travels very fast, its experience of time slows down compared to someone who is relatively still. Muons move at extraordinary speeds, so fast that they are very close to the maximum speed allowed by the universe. And because of that, something subtle happens. From our perspective, standing here on Earth, we measure their lifespan. We say they should last only a tiny fraction of a second. And from our point of view, that is correct. But from the muons' perspective, something different is happening. Its internal clock is not ticking at the same rate as ours. Time for the muon is passing more slowly. So while we see it travelling a long distance in what seems like a brief moment, the muon itself experiences even less time during that journey. From its perspective, it has not yet had the chance to decay. It has not yet reached the end of its short existence, and so it continues. It survives the journey. It reaches the ground. What appears impossible from one point of view, it becomes completely natural from another. And when you take this effect into account, the numbers begin to match perfectly. The number of muons detected at the surface aligns with what we expect. Once we recognize that time is not the same for them as it is for us. This was one of the earliest clear pieces of evidence that time can behave differently depending on motion. Not as a theory, not as a thought experiment, but as something measurable, something real, something happening constantly all around us. And if you pause for a moment and let that sink in, something remarkable begins to emerge. Because what these tiny particles are doing in their brief, silent journey from the sky to the earth is a form of time travel, not backward, not in a dramatic sense, but forward. They are moving into our future faster than they otherwise would. They are experiencing less time than we are, and so, from our perspective, they seem to persist longer. They seem to outlive their expected lifespan. But in truth, they're simply taking a different path through time, a path shaped by their incredible speed. Now imagine extending this idea, not to particles, but to people. If something as small as a muon can experience time differently, then in principle, so can anything else, including you. If you could travel fast enough, if you could move through space at speeds approaching that same cosmic limit, then your experience of time would begin to change as well. Your clock would tick differently, your moments would stretch, and when you returned, you would find that more time had passed for others than for you. You would have stepped forward into their future, not by skipping time, not by jumping, but by moving through it differently. And while the speeds required for dramatic effects are far beyond what we can easily achieve, the principle itself is already part of reality, already proven, already observed, and all of it revealed not by grand machines or distant theories, but by tiny particles drifting silently down from the sky, particles that lived longer than they should have, not because the rules were broken, but because the rules were deeper than we first imagined. And as we begin to shift our focus from these fleeting travellers to something closer to home, we will see that this quiet bending of time is not limited to the microscopic world. It touches human lives as well, in ways that are subtle but real, and sometimes deeply moving. If the story of those tiny particles feels distant, if it still seems like something happening far above us in a world too small to see, then it helps to bring the idea closer to something familiar, closer to something human. Imagine two people. They begin together, standing side by side, sharing the same moment, the same place, the same quiet beginning. They might be siblings, perhaps even twins. Their lives unfold together at first, the same days, the same seasons, the same passing of time, and then, at some point, their paths diverge. One of them leaves, not just for a short journey, but for something far more extraordinary. They step into a spacecraft. It lifts gently at first, rising away from the Earth, carrying them upward into the vastness of space. As the journey continues, the spacecraft accelerates, faster and faster until moving at a speed that begins to approach the natural limit of the universe, not quite reaching the speed of light, but coming close enough for something subtle to begin changing. Inside the spacecraft, everything feels normal. The traveller breathes as they always have. Their thoughts move at the same pace. A clock beside them ticks steadily, second by second. Nothing seems different. But far away on Earth, something else is happening. The twin who remained behind continues living their life. Days pass, then months, then years. From their perspective, time moves forward as it always has, but from their point of view, watching the distant traveller, something strange begins to appear. The traveller's time seems to slow. Their movements stretch ever so slightly. Their clock ticks, but not in perfect step with the one on Earth. And this difference, though subtle at first, grows with time. Eventually the journey ends. The spacecraft turns, it makes its way back, and after a long absence, the two are reunited. They stand once again side by side, but now something has changed. The traveller has aged less, not by illusion, not by perception, but in reality. Fewer moments have passed for them, fewer seconds, fewer days, fewer years. While their twin on Earth has moved steadily forward through time, the traveller has taken a different path, a path where time unfolded more slowly. And so, when they return, they arrive not just from a distant place, but from the future. They have stepped forward in time, relative to the world they left behind. This idea is often called the twin paradox, but there is no contradiction in it, no true paradox. Only a difference in perspective, a difference in how each person moved through space-time. Because earlier, we spoke of a kind of balance, a quiet trade between motion through space and motion through time. The traveller spent more of their motion moving through space, and so less remained for moving through time. Their journey through time was stretched, slowed, and this is not something imagined. It is not a thought experiment alone. Versions of this have already happened, not with journeys spanning centuries, not yet, but in smaller, measurable ways. There are astronauts who have spent extended periods in space, orbiting the Earth at high speed, moving faster than those of us on the ground, and when their time in orbit is compared to clocks on Earth, a difference can be measured. Tiny, almost unimaginably small, but real. The astronaut has aged ever so slightly less. Even on Earth, motion plays a role. Airplanes flying across the sky, satellites circling the planet, all experience time just a little differently. Clocks carried on fast-moving journeys tick at slightly different rates than those left behind, and these differences have been measured carefully, repeatedly, always with the same quiet conclusion. Time is not absolute. It does not pass at the same rate for everyone. It depends on how you move. Now, of course, for the effects to become dramatic, for someone to truly leap far into the future, the speeds required are enormous, close to the speed of light, speeds far beyond what we can easily achieve, and so, for now, the differences remain small, measured in fractions of a second, but the principle remains, and the principle is what matters, because it tells us something profound. Time travel to the future is not forbidden, it is not speculative, it is not a dream waiting to be realized. It is already part of reality, already happening, already woven into the fabric of how the universe works. Every time something moves, especially at high speed, its path through time shifts, gently, quietly, but unmistakably. And if you imagine pushing this further, if you imagine a journey that lasts long enough, fast enough, distant enough, then the difference grows. Years could pass on Earth, while only months pass for the traveller. Centuries could pass, while only a lifetime unfolds within the spacecraft, and when they return, they would find a world that has moved on without them, a future that, for everyone else, arrived slowly, but for them, arrived all at once. It is a strange kind of journey, not one that lets you revisit what has been, but one that allows you to step beyond what others have yet to reach, a quiet leap forward, and as you sit with that idea, something begins to feel different, because time travel in this direction no longer feels impossible. It feels inevitable, a natural consequence of how space and time are intertwined, and as we continue to explore this, moving from motion through space to something even more subtle, we will find that speed is not the only way to shape time. There's another influence, one that does not require movement at all, only presence, only gravity, and it too bends time in its own quiet way. If moving quickly through space can gently stretch time, then it may feel natural to think that speed is the only way this happens, that if you want to experience time differently, you must travel far and fast. But the universe has another way, a quieter one that does not require motion at all, only presence, only gravity. To begin to feel this, imagine a simple clock, not a digital display, not something complex, just a gentle, steady ticking, one tick, then another, marking the passage of time. Now imagine you have two identical clocks, perfectly synchronized. They begin together, ticking in unison. Now take one of those clocks and move it somewhere different, not far in space, but deeper into gravity. Imagine placing it at the base of a mountain, or more gently still, imagine lowering it closer to the surface of the Earth, where gravity is slightly stronger. The second clock remains higher up, perhaps on a mountaintop, or even further away from the Earth. Both clocks continue ticking, quietly, steadily. But something subtle has changed. The one deeper in gravity begins to tick more slowly, not in a way you would notice with your senses, not in a way that would disturb your daily life, but in a way that can be measured, carefully, precisely. And over time, the difference grows. The two clocks, once perfectly aligned, begin to drift apart, one falling slightly behind the other. It is as if gravity itself is gently stretching time, holding it back, slowing its passage. And once again, this is not a metaphor. It is not a story. It is something that has been observed, measured, confirmed, in laboratories, in mountains, and even across distances as small as the height of a room. Modern clocks are so precise, so sensitive, that they can detect differences in time caused by changes in height of just a few centimeters. Move a clock slightly higher, where gravity is weaker, and it will tick just a little faster. Move it lower, where gravity is stronger, and it will tick just a little slower. The effect is incredibly small, but it is real, and it reveals something profound. Time does not pass equally everywhere. It depends not only on how you move, but on where you are, on the gravitational environment around you. And to understand why this happens, it helps to return to the image we touched on earlier. The idea that space-time is not flat, not rigid, but curved. Imagine again a surface, like a stretched sheet. If you place something heavy on it, the surface bends, it dips, and anything moving nearby will follow that curve, not because it is being pulled in the usual sense, but because the space it moves through is no longer straight. Gravity in this view is not a force pulling objects together, it is the shape of space-time itself, and when space-time bends, time bends with it. Near a massive object, where the curvature is stronger, time slows down. Further away, where the curvature is gentler, time moves more quickly. And so, two observers, one deeper in gravity, one further away, will experience time differently, each living their own rhythm, each following their own path through time. Now, once again, this may feel distant, abstract, something that matters only in extreme environments, near stars or black holes. But in truth, it touches your life every day, quietly, constantly, in ways you may never have noticed. Consider something familiar, a map on your phone, a navigation system guiding you through streets and turns. It feels simple, immediate, accurate. But behind that simplicity lies something delicate, a network of satellites orbiting high above the Earth, each one carrying extremely precise clocks. These satellites move quickly, faster than we do on the ground, and they are also further from the Earth, where gravity is slightly weaker. Both of these factors affect how their clocks tick. Because of their speed, their time slows down slightly. Because of their position in weaker gravity, their time speeds up slightly. Two effects, working in opposite directions, and both must be taken into account. If they were ignored, even for a short time, the system would drift. Positions would become inaccurate, errors would grow, and within a short while the map would no longer match the world. But because we understand how time behaves, because we account for these differences, the system works seamlessly, quietly, guiding you without you ever needing to think about the strange behavior of time that makes it possible. And so, in a very real sense, you're already relying on time travel. Every time you check your location, every time you follow a route, you're using a system that depends on the fact that time does not pass equally everywhere, that clocks can disagree, that time can stretch and compress, depending on motion and gravity. And when you step back and look at this more broadly, something remarkable becomes clear. Time travel to the future is not just possible. It is not just a theoretical prediction. It is something we observe, something we measure, something we use all the time, not in dramatic leaps, not in journeys across centuries, but in tiny differences, accumulating, real and consistent. And yet, as we return to the question that began all of this, something else begins to take shape. Because moving forward, stretching time, is one thing, but turning around, returning to what has already happened, that is something else entirely. Because if the future is open to us, shaped by how we move, the past seems to remain just out of reach. And so, gently, we begin to shift from what is possible to what may not be, from the quiet certainty of forward motion to the deeper mystery of whether the path can ever be reversed. If moving forward through time can be stretched, if clocks can drift apart, if the future can be reached a little faster by changing how you move, then it feels natural to ask a simple question. If we can lean forward in time, can we turn around? Can we go back? At first, it might seem like the answer should be yes. After all, we have seen that time is not fixed. It bends, it stretches, it behaves differently depending on motion and gravity. So perhaps, under the right conditions, it could bend far enough to loop, far enough to return. But as we begin to explore this idea, we quickly encounter something firm, something that does not bend so easily, a limit, the speed of light. Earlier, we spoke of it as the maximum speed anything can travel, but it is more than that. It is a boundary woven into the structure of space-time itself. To understand why this matters, imagine once again that you are moving through the universe. At ordinary speeds, your motion feels simple. You move through space, and time flows steadily. But as you go faster, something begins to change. Your motion through time slows, Your clock ticks more slowly compared to those who are still, and the faster you go, the stronger this effect becomes. But there is a deeper consequence as well. As you approach the speed of light, something begins to resist you. It becomes harder and harder to accelerate, harder to go faster, as if the universe itself is gently pushing back. And the closer you get to that ultimate speed, the more extreme this resistance becomes. To go just a little faster requires more energy, then more, then far more, until in theory, to reach the speed of light itself would require an unlimited amount of energy, an amount so large that it cannot be supplied, not by any machine, not by any process we understand. And so, the speed of light becomes not just a limit, but a wall, something you can approach, but never quite reach, and certainly never exceed. Now, this matters deeply for time travel, because earlier we saw that your path through spacetime must remain within certain boundaries, that there are limits to what you can reach based on how fast you can move. And to reach the past, to return to an earlier moment, you would need to go beyond those limits. You would need to step outside the region that is normally accessible. In simple terms, you would need to move faster than light, because only by doing so could you outrun the natural progression of time. Only by doing so could you arrive somewhere before you left. But if the speed of light cannot be reached, let alone exceeded, then that path seems closed, not because it is forbidden by a rule, but because it is unreachable. And yet, for a brief moment in recent history, it seemed as though this barrier might have been broken. In the early part of the 21st century, a group of scientists made an announcement that sent a ripple through the world of physics. They had been studying tiny particles called neutrinos, particles that rarely interact with anything, particles that pass through matter almost as if it were not there. They had sent these particles on a journey, from one location to another, deep beneath the Earth, a controlled path, carefully measured, and when they examined the results, they found something unexpected. The neutrinos appeared to arrive slightly earlier than they should have, not by much, just a tiny fraction of a second, but enough to suggest something extraordinary, that they had travelled faster than light. If true, this would change everything, because if something can move faster than light, then the structure of space-time itself begins to open in new ways. Paths that were once forbidden might become possible, and among those possibilities would be travel into the past. The idea was electrifying. For a moment, it felt as though the door had opened, that the universe had revealed a hidden pathway. But science moves carefully, patiently. Results are checked, tested, questioned, and as the investigation continued, a quieter answer began to emerge. There had been a mistake, a small error in the experimental setup, a connection that was not quite right, a timing system that introduced a slight discrepancy. When the error was corrected, the result disappeared. The neutrinos had not broken the speed limit after all. The wall remained intact, and while this might seem disappointing, it carries its own kind of meaning, because it reminds us that the structure of the universe is consistent, reliable. The rules that govern it are not easily broken, and so we return to where we began, with a limit, a boundary that cannot be crossed, and with it, a quiet conclusion. If travelling faster than light is required to move backward through time, and if travelling faster than light is not possible, then returning to the past, in the simplest sense, may be beyond our reach, at least in the way we might first imagine. And yet, as with so many things in physics, the story does not end there. Because while we cannot break the rules, we may still find ways to work within them, to bend them, to explore their edges, to discover paths that do not require us to move faster, but instead change the shape of the space we move through. And as we begin to follow that idea, we step into a deeper part of the story, a place where paths through time may not be straight, where they may curve, and under the most extreme conditions, perhaps even return. If the speed of light stands as a boundary, if it quietly prevents us from simply outrunning time, then it might seem as though the path to the past is completely closed, a door that cannot be opened, a direction that cannot be reached. And yet, as we step a little deeper into the structure of space-time, something unexpected begins to appear. Not a loophole, not a break in the rules, but a different way of looking at the path itself. Because until now, we have imagined your journey through time as something simple, a line, a gentle, continuous path, always moving forward, never turning back. But what if that path is not always straight? What if, under certain conditions, it could bend? To explore this idea, it helps to return to something familiar. Imagine walking along a long road. You begin at one point and you walk forward, step by step. The distance behind you grows. The place you started becomes further and further away. It feels natural to say that you cannot return to it, not without turning around, and in time it may seem so distant that it feels unreachable. But now, imagine that the road itself is not straight. Imagine that it curves, gently at first, then more sharply, until, without you ever turning around, the road brings you back to where you began. You're still walking forward. You have not reversed your direction, and yet you have returned. The path itself has done the work. It has looped and carried you back. This is the kind of idea that begins to emerge when physicists explore the deeper possibilities of space-time. Because space-time is not fixed and flat. It can curve, it can twist, and under extreme conditions, those curves can become so strong that paths through time begin to bend in unusual ways. In mathematical descriptions of space-time, there are solutions, shapes, where a path through time can loop back on itself, where an object following its natural path can eventually arrive at an earlier moment, not by breaking the rules, not by exceeding the speed of light, but by moving through a region of space-time that is itself curved in a very particular way. These paths are often called closed, time-like curves, but again, the name is less important than the image. A path that closes, a journey that returns, a line that forms a loop. Now, this may sound like something purely theoretical, something that exists only in equations, but the equations themselves come from our best understanding of gravity, of space-time, of how the universe behaves. They are not invented lightly. They are derived from principles that have been tested again and again in many different ways, and within those principles, these looping paths appear quietly, consistently, as possibilities. Now, it is important to be gentle with this idea, because the existence of such paths in theory does not mean they exist in reality. It does not mean they can be created, or accessed, or used. But it does mean that the structure of space-time, at least as we understand it, does not completely forbid them. And that alone is enough to change the way we think, because earlier we imagined that travelling to the past would require us to move faster than light, to outrun time itself. But here, something different is happening. The path itself is changing, the structure is bending, and by following that path, always moving forward, we may arrive somewhere that feels like the past, without ever breaking the speed limit, without ever stepping outside the rules. This is a subtle shift, but an important one. It suggests that time travel, if it is possible, may not come from pushing harder, moving faster, or overcoming limits. It may come from understanding the shape of the space we move through, from finding regions where the structure of space-time itself allows for unusual paths. But as you sit with this idea, something else begins to emerge. Because while the image of a looping path is elegant, even beautiful, it carries with it a quiet tension. If such a path exists, if it allows you to return to an earlier moment, then all of the paradoxes we explored before begin to reappear if you follow a loop and arrive in your own past. What happens then? Do you meet yourself? Do you change something? Do you create contradictions? Or does the structure of the path somehow prevent those contradictions from forming? These questions do not have simple answers, and in many ways they lead us deeper into the mystery. But before we explore them, before we try to understand how such paradoxes might be resolved, there is another step to take. Because while these looping paths may exist in theory, they require something extraordinary. They do not appear in ordinary space. They do not form under gentle conditions. They emerge only when space-time is pushed to its limits, when gravity becomes extreme, when motion becomes intense, when the structure of the universe is stretched, twisted, shaped in ways far beyond everyday experience. And so, naturally, the next question arises. If such paths are possible, what would it take to create them? What kind of environment? What kind of object? What kind of machine could bend space-time enough to form such a loop? And as we begin to explore those possibilities, we step into a world that feels almost like science fiction, and yet is rooted in the same equations, the same understanding that has guided us this far. If a path through time can in principle bend back on itself, if the structure of space-time can curve so deeply that a journey forward leads you back to where you once were, then a quiet question begins to take shape. Not whether such paths can exist in theory, but whether they could ever be created, whether there is something, somewhere, that could bend space-time enough to form such a loop. And as physicists explored this idea, they found that while nature does allow for such possibilities, it asks for something in return, something immense, something far beyond anything we encounter in everyday life. To begin to understand this, imagine once again the fabric of space-time, not as a rigid grid, but as something flexible, something that can bend under the presence of mass and energy. We have already seen gentle versions of this. The Earth curves space-time slightly, the Sun curves it more strongly, and massive objects like black holes curve it so deeply that even light struggles to escape. Now imagine pushing this idea further. Imagine trying to shape space-time deliberately, not just observing its curvature, but engineering it, guiding it into a form that allows paths to loop. One of the earliest ideas along these lines came from a simple yet strangely powerful image. A cylinder, long, dense, and rotating. If such an object were massive enough, and if it spun fast enough, could twist the surrounding space-time, not just bending it downward as gravity does, but dragging it around, wrapping it. And if the rotation were extreme, the effect could become strong enough to tilt the structure of space-time itself. Paths that once pointed forward in time could begin to lean, and under just the right conditions, they might tilt far enough to form a loop. A path that returns. This idea is sometimes associated with what is known as a rotating cylinder model, but even without the name, the picture is enough. A massive object spinning so rapidly that it reshapes the very directions of space and time around it. And yet, as intriguing as this idea is, it comes with a quiet limitation. The cylinder would need to be extraordinarily long, possibly extending infinitely, and it would need to rotate at unimaginable speeds, far beyond anything we could construct, far beyond anything we even know exists. And so, while the mathematics allows it, the reality seems out of reach. But the story does not end there, because another idea emerged, one that feels, in some ways, more familiar, more intuitive, a bridge, not through space alone, but through space-time. Imagine taking a sheet of paper, draw 2 points on it, far apart. If you move across the surface, it takes time to travel from one to the other. But now, fold the paper, bring the 2 points close together. Suddenly, the distance between them is no longer defined by the surface, but by the fold. You can move directly from one point to the other in an instant. This is the basic idea behind what is often called a wormhole, a tunnel through space-time, a shortcut, a way of connecting two distant regions, not by travelling through space, but by altering the structure itself. And if such a structure could exist, if it could be stable, if it could remain open, then something remarkable becomes possible. Because the two ends of this tunnel, the two mouths, could experience time differently. Imagine taking one end of the tunnel and moving it, accelerating it, carrying it on a long journey at high speed, or placing it in a region of strong gravity. As we have seen, time would pass differently there, slower compared to the other end. Then, when the journey is complete, the two ends are brought back together. They are now in the same place, but not in the same time. One has aged less. One is effectively in the past, relative to the other. And if you step through the tunnel, from one end to the other, you could emerge at a different point in time, not by moving faster than light, but by moving through a structure that connects different moments. It is an elegant idea, almost poetic, but once again, it comes with challenges, because keeping such a tunnel open, preventing it from collapsing, requires something unusual, something not commonly found in the universe, a kind of energy that behaves differently from what we normally encounter, energy that can, in a sense, push outward, counteracting the natural tendency of the tunnel to close. This is sometimes described as negative energy, and while small hints of such behaviour appear in certain quantum effects, they are fleeting, tiny, difficult to harness, and far from what would be needed to stabilise something as large as a wormhole. There are other ideas as well, long, thin structures that might stretch across the universe, known as cosmic strings. If arranged and moved in particular ways, they might also bend space-time sufficiently to allow unusual paths. But again, these are extreme scenarios, requiring conditions that are rare, or perhaps non-existent. And so, as we gather these ideas together, a pattern begins to emerge. The universe, it seems, does not completely forbid the possibility of time travel to the past. The equations allow it, the structure permits it, under certain conditions. But those conditions are extraordinary, demanding, difficult to realize. It is as if the door is not locked, but hidden behind layers of complexity, guarded not by rules, but by the sheer scale of what is required. And so we arrive at a quiet understanding. Time travel to the past may not be impossible, but it is not easy. It is not something that can be achieved with simple machines or clever tricks. It would require shaping the universe itself, folding it, twisting it, bending it into forms that lie at the very edge of what is physically possible. And even then, questions remain. Because if such a journey could be made, if one could step back into an earlier moment, what would happen next? Would the paradoxes return? Would the loops form again? Or would the universe respond in some deeper way, preventing contradictions before they arise. To explore that, we must look not at the large scale of space-time, but at something much smaller, something stranger, the world of the very small, where certainty dissolves and possibilities begin to multiply. As we leave behind the vast scale of space-time, the bend-in of entire regions of the universe, the immense structures required to twist time itself, we arrive somewhere much smaller, quieter, and in many ways, far stranger. Because at the smallest scales, the universe does not behave in the way we expect. It does not follow the steady, predictable paths we have been imagining. Instead, it becomes uncertain, fluid, almost dreamlike. To begin to feel this, imagine a simple room, not large, not elaborate, just a quiet enclosed space. Inside the room there is a person, you, and something else, something hidden from view, a mechanism, a process. It is set in motion, and once it begins, its outcome is uncertain. There is a chance that nothing will happen, and there is a chance that something will, something final. From the outside, the room is sealed. No one can see inside. No one can know what has happened. Not yet. And so, from the perspective of an observer standing outside the room, something very strange must be said. Until the room is opened, until the outcome is revealed, the person inside is both alive and not alive. Not in the sense of confusion, not in the sense of indecision, but in a very real physical sense. The state has not yet been resolved. It exists in a kind of overlap, a blending of possibilities. This idea may feel uncomfortable, it may feel like a contradiction, but it arises naturally from the way the smallest parts of the universe behave. At that scale, particles do not have definite positions or definite states until they are observed. Instead, they exist in what can be thought of as a spread of possibilities, a cloud of potential outcomes. Only when an interaction occurs, when something is measured, does one of those possibilities become real. Before that, they all coexist. This is sometimes called superposition, but again, the word is less important than the feeling, because it suggests that reality, at its most fundamental level, is not a single, fixed story. It is a collection of possible stories, all present at once. Now, when we bring this idea into the room, when we apply it to something as familiar as a human life, it becomes more difficult to hold, because we're not used to thinking of ourselves this way. We experience one path, one sequence of events, one outcome, but at the smallest level. The underlying reality may be far richer, far less singular. And as strange as this sounds, it has been confirmed in countless experiments, not with people, of course, but with particles, with systems, with carefully controlled conditions where outcomes can be observed. Again and again, the results show the same pattern. Before observation, multiple possibilities exist. After observation, one is selected, and yet the others do not simply vanish without a trace. They remain part of the mathematical description of the system, part of the deeper structure. And this is where something subtle begins to connect. Because earlier, we spoke of time as a structure, a landscape, something already laid out. Now we're seeing that at the smallest scales, reality itself may not be singular. It may not be one fixed path, but a range of possibilities. And if that is true, then the question of time travel begins to shift once more. Because perhaps the paradoxes we encountered earlier, the loops, the contradictions, the questions of cause and effect, do not arise because time travel is impossible, but because we are imagining it within a framework that is too simple, a framework where only one outcome can exist. But what if that is not the case? What if, when different possibilities arise, they're not forced into one outcome, but instead continue separately, quietly, independently, like branches? At this point, the idea is still forming, still soft, still undefined, but it carries a certain feeling, a sense that the universe may not resolve contradictions by preventing them, but by allowing different outcomes to exist without interfering with each other. And as we sit with this, something else becomes clear. Because while the image of the room may feel unsettling at first, it does not need to remain that way. You do not need to hold both outcomes at once. You do not need to resolve the uncertainty. Instead, you can simply observe the idea, let it drift, let it pass through your thoughts, like a cloud moving slowly across the sky. Because the purpose here is not to create tension, not to force understanding, but to gently expand the space of what feels possible, to allow the idea that reality and time may be more flexible than they first appear. And as this idea settles, softens, becomes more familiar, we are ready to take one more step, to explore what happens if these multiple possibilities are not just theoretical, but real, if they form separate paths, separate timelines, separate versions of events, each one unfolding quietly in its own way. If you let that quiet room fade gently from your thoughts, if you allow the uncertainty to settle without trying to resolve it, something new begins to take shape, not as a contradiction, but as a possibility. Because earlier, we imagined that when a moment is uncertain, when multiple outcomes are possible, only one becomes real. The rest simply disappear. But what if that is not what happens? What if nothing is discarded? What if every possibility continues, not together, not overlapping in a confusing way, but separately, quietly, like branches extending from a single point? To feel this more clearly, imagine something simple, a decision, a small one. You're standing at a crossroads. You can turn left or right. From your perspective, you choose one. You take a step, and the other path is left behind. It feels as though one future has been selected and the other has vanished. But now, imagine something different. Imagine that both paths continue. In one version of events, you turn left. In another, you turn right. Each version unfolds independently. Each one feels complete. From within either path, it feels as though it is the only one. But from a wider perspective, both exist. This idea is sometimes described as the many worlds interpretation, but again, the name is not the important part. What matters is the image, a universe that branches, not once, but continuously, at every moment where multiple outcomes are possible, each branch forming its own path through time, each one real in its own way. Now, this may sound overwhelming, an endless number of possibilities, an ever-growing tree of outcomes, but there is a quiet simplicity to it as well, because it removes the need for certain contradictions. If every possibility is allowed to exist, then conflicts between them no longer need to be resolved within a single timeline. They simply unfold separately, and this brings us back, gently, to the paradoxes we encountered earlier. The letter that had no origin, the loop that closed on itself, the question of whether you could return to the past and change something in a single, fixed timeline. These ideas create tension. They seem to require something impossible, but in a branching structure, something else becomes possible. Imagine, once again, that you travel backward. You arrive in what appears to be your past. You see familiar places, familiar moments, but perhaps, quietly, without noticing, you are no longer in the same timeline. you have entered a branch, a version of events that resembles your past, but is not identical to the one you came from. And in this branch, your actions can unfold freely. You can make different choices. You can alter events, not because you have changed your own past, but because you are now part of a different path. Your original timeline remains unchanged. Your history remains intact, but alongside it, another version now exists, a new branch, a new story. And in this way, the paradox dissolves. There is no contradiction, because there is no single thread that must remain consistent. There are many threads, each one following its own course. Now, this idea extends further, because if every possibility continues, then there may be versions of you that experienced different outcomes, versions that made different choices, versions that lived different lives, not as ghosts, not as illusions, but as real, complete paths through space-time, each one as valid as the one you experience, and while you remain within your own path, your own thread. The existence of others does not interfere. They unfold quietly, beyond your awareness. This leads to a curious and slightly unsettling thought, because if there are always branches where different outcomes occur, then there may always be a branch where you continue, where events unfold in such a way that your path does not end, where each uncertain moment resolves in a way that allows your experience to go on. This idea is sometimes referred to as quantum immortality, but it is important to approach it gently, not as a claim, not as a certainty, but as a possibility that emerges from the logic of branching timelines, a suggestion that in the vast landscape of possibilities, there may always be paths where certain outcomes persist, and yet, even this idea does not need to be held tightly. It can remain soft, a thought to be observed, rather than believed. Because what matters here is not the conclusion, but the shift in perspective, the realization that reality, at its deepest level, may not be a single, fixed story, but a collection of stories, each one unfolding in its own way. And within this broader picture, time travel becomes something different, not a journey that alters a single fragile timeline, but a movement between branches, a transition from one path to another. And in that movement, the paradoxes lose their sharp edges, they soften, they become questions of perspective rather than contradictions. And as this idea settles, quietly, gently, we begin to see that there may be more than one way for the universe to handle the challenges of time travel. It may prevent contradictions entirely, it may enforce consistency, or it may allow multiple outcomes to exist side by side, each possibility offering its own way of resolving the tension. And as we bring these ideas together, we move toward a final understanding, not a single answer, but a set of possibilities, each one reflecting a different way of seeing time and reality itself. As these different possibilities begin to settle, as the idea of branching paths, looping journeys, and flexible time becomes more familiar, a quiet question remains. If time travel were ever possible, if someone could return to an earlier moment, what would stop things from breaking? What would prevent contradictions from forming? Because even with all the ideas we have explored, the concern still lingers, the possibility that something could happen that should not, that an action taken in the past could erase its own cause, that a loop could collapse under its own logic. And so, over time, physicists began to ask a different kind of question. Not, can time travel exist, but rather, if it does exist, how does the universe protect itself? How does it remain consistent? One possibility is surprisingly simple. Perhaps the universe does not allow such journeys at all, not because they are logically impossible, but because the conditions required to create them can never be fully realized. This idea is often associated with a physicist named Stephen Hawking. He suggested that there may be a kind of natural safeguard built into the laws of physics, a way of preventing time loops from forming, a quiet protection of the timeline, not through force, but through impossibility. In this view, as one tries to create the conditions necessary for time travel, something always intervenes. Energy requirements grow too large, instabilities appear, the structure collapses before the loop can form. It is as if the universe gently closes the door, just before it can be opened. This idea is sometimes described as a kind of chronology protection. But the phrase itself is less important than the feeling, the sense that the universe preserves its own consistency by preventing situations that would break it. And in a way, this aligns with what we have already seen, because many of the models that allow time travel require extreme conditions, exotic energy, perfect alignment, unstable configurations, all of which suggest that even if the mathematics allows it, reality may not. But there is another possibility, one that does not prevent time travel, but shapes it. This idea suggests that if a loop in time exists, then it must be self-consistent. In other words, everything that happens within that loop must already fit together. No contradictions can arise, because the events are already part of a consistent structure. To understand this, return once more to the story from the beginning. The letter, the loop. You receive a message, you follow it, you build the machine, you return, and you deliver the same message. At no point does anything conflict. At no point does the loop break. It simply completes itself. In this view, if you were to travel back in time, you could not change events in a way that creates a contradiction, not because you are prevented from acting, but because any action you take is already part of what has happened. If you attempt to do something that would break the loop, something will intervene, not as an external force, but as a natural outcome. Circumstances will align in such a way that consistency is preserved. This idea is often associated with what is called a self-consistency principle. But again, the name is not essential. What matters is the image, a loop that holds together, a story that cannot contradict itself, because every part is already woven into the whole. In this view, time travel becomes less about changing the past and more about fulfilling it, becoming part of the events that have already occurred, completing a pattern rather than rewriting it. And then there is a third possibility, one we explored just moments ago, the idea that the universe does not force a single outcome at all, that instead it allows multiple outcomes to exist. In this view, if you travel to the past and make a different choice, you do not overwrite your own history. You create a new branch, a separate path. The original remains untouched. The contradiction dissolves because it is no longer contained within a single timeline. Each version unfolds independently, quietly, without conflict. And so, we are left with three gentle possibilities. The universe may prevent time travel entirely. It may allow it, but only in ways that remain perfectly consistent. Or it may allow multiple outcomes, separating them into different paths. Each one offers a way to preserve coherence, to maintain the integrity of the structure. And perhaps the most important thing to notice is that in all three cases, the universe does not become chaotic, it does not collapse under contradiction, it remains stable, ordered, whole, which suggests something deeper, that the laws of physics are not just rules for how things move, but rules for how consistency is preserved, for how reality holds together, even in the presence of possibilities that seem at first impossible. And as we step back, as we look at the full picture that has slowly unfolded, something begins to settle, not as a final answer, but as quiet understanding. That time, whether it flows or not, whether it branches or loops, is part of a structure that is far more subtle, far more intricate than we once imagined, and that whatever the truth may be, it is not careless, it is not random, it is something that, in its own quiet way, makes sense. And so, after moving through stories, experiments, ideas, and possibilities, we arrive somewhere quiet again, not at an answer, but at a perspective. Because the question we began with was simple: is time travel possible? And along the way, the answer has become both clearer and more subtle. We have seen that in one direction. The answer is already yes, not in some distant future, not in a laboratory yet to be built, but here, now, all around you. Every moment that passes, you are moving forward. That part has always been true. But what we've discovered is that this movement is not the same for everyone. It is not fixed, not universal. Time can stretch, it can slow, it can flow at different rates, depending on how you move and where you are. Tiny particles falling from the sky live longer than they should, travellers moving at great speed, return having aged less, clocks placed at different heights quietly drift apart, and the systems we rely on every day account for these differences so seamlessly that we rarely notice. All of this leads to a simple, gentle realization. Time travel to the future is not just possible, it is real. It is part of the structure of the universe, a natural consequence of how space and time are woven together. And yet, when we turn our attention to the past, the story changes, because returning to what has already happened proves far more difficult. The speed required to simply outrun time cannot be reached. The energy needed grows beyond anything we can provide, and so the most direct path remains closed. But even then, possibilities remain. Paths that bend, structures that curve, regions where space-time itself might allow unusual journeys, loops, bridges, connections between moments. And while these ideas are grounded in the same physics that describes our world, they require conditions so extreme that they remain far beyond our reach, at least for now. And even if such journeys were possible, the question of what would happen next remains open. Would the universe prevent contradictions altogether? Would it enforce a perfect consistency, where every action fits into a single unbroken story? Or would it allow multiple paths, branching quietly, each one unfolding without conflict? We do not yet know. Perhaps we may never know. But there is something else we've learned along the way. Something that does not depend on whether time travel to the past is possible. Something that is true, regardless of the answer. That time itself is not what it first appears to be. It is not simply a flow carrying us forward. It is not just a sequence of moments, appearing and disappearing. It may be something more like a landscape, a structure, a vast quiet arrangement of events, each one existing in its own place, and you are not just moving through it, you are part of it, a path stretching from what you call your past to what you call your future, every moment of your life already part of that path, already part of the shape of space-time, and what you experience, what you feel as the present, is simply where you are along that path. A point of awareness, a place where your attention rests. This does not take away meaning. It does not remove choice, because even if the path exists, you are still the one walking it, still the one experiencing each moment, still the one giving it life. And perhaps that is what matters most. Not whether we can escape time, but how we move within it, because time is not chasing you. It is not something you are running out of. It is something you are within, something you are part of. And as you sit here, listening, drifting gently between thoughts, you are already travelling, quietly, effortlessly, through a structure that holds every moment, past, present, and future, together. Not rushing, not forcing, just moving. And so, we come back to the question one last time. Is time travel possible? Yes, in the direction we are already going. And perhaps, in other ways, at the edges of what we understand. But more than that, time itself may not be something to travel through. It may be something that already holds you, like a landscape at rest, like a story already written, like a quiet river that was never flowing, only waiting as you drift through it. And so, we've reached the end of tonight's exploration. Whether your eyes are still open, or you're already floating somewhere between waking and dreaming, thank you for being part of this little journey. If you'd like to join me again for more gentle wanderings, you're always welcome to subscribe or share this with someone who could use a peaceful pause. Time has a way of slipping through our fingers, but here, in this quiet moment, it's just you and the soft hush of rest. Sleep peacefully, wherever and whenever you may be.